Good afternoon, everyone. I'm Ben Baker from Juniper Networks, and welcome to part 2 of our 3-part blockchain webinar series. Last time in part 1, we explored what blockchain is, what problems it solves, and what Juniper's point of view is on this clever new technology. Today, we'll briefly discuss a range of potential blockchain use cases. We'll think through how you can assess blockchain potential opportunities, and we'll look at blockchain's weaknesses. And finally, we'll discuss the role that Juniper plays as you begin this path to experimenting with blockchain. So let's jump right into the use cases. The potential of blockchain touches nearly every industry imaginable. So that's both verticals and horizontals, if you will, such as supply chain, IoT. But keep in mind that virtually every blockchain application that you might hear about out there today is not proven in full-scale production environment. And this slide is really just the tip of the iceberg in terms of blockchain use cases that we've seen or that we think have potential. Definitely not an exhaustive list. And I'll go through some of these. First, FSI, financial services. This is the area where most activity is occurring right now. Certainly cryptocurrencies such as Bitcoin and Ether. And I heard recently that if you had invested $1,000 in Bitcoin in 2012, you'd have $40 million today. So it's hard to imagine that there isn't a bubble aspect to those valuations. But anyway, there is a lot of other blockchain activity going on in FSI. Trade finance, cross-border payments, clearing and settlement, KYC, know your customer. A lot of tricky problems around reconciliation and identity in the finance world that today require complex processes and time, as in days, to settle. Just one example, R3 is a consortium of big banks looking to use blockchain to solve many of these problems. Next, supply chain smart contracts, which we touched on in part 1 of this webinar series, can be used to automate supply chains and improve overall efficiency. And provenance issues, this idea of origin, ownership, authenticity of parts, this can be solved if you track a part on a blockchain from the point at which it's created all the way through to its end use. And fraudulent parts is a problem in the aircraft industry, for example. Next, energy. The Brooklyn microgrid is an interesting example where distributed ledgers and smart contracts are disrupting, disintermediating the utility industry, allowing consumers to produce energy themselves from solar panels on their roofs and sell that energy in peer-to-peer style to their neighbors. Music. A lot of complexities and inefficiencies around copyrights and royalty payments, and often transactions around a song, for example, can be a few cents. So there's an opportunity for smart contracts here to shine a little bit of light on some of the lack of transparency in this industry. Art, fine wine, again, provenance and authenticity problems here. How do you know that $200 bottle you just bought is a 2003 Paul Hop? Telco. Many scenarios within networking where trust between parties is difficult to establish and even tougher to audit. But we'll take a look at telco use cases in blockchain in more depth in part 2 of this webinar series. And finally here I'll mention IoT. We think blockchain will really solve some tough problems in managing the interactions of and verifying the identity of hundreds, thousands, millions of devices out there, and doing this at scale in an efficient way. So the list of potential use cases is incredibly wide and long, and of course you can start narrowing down this list depending on the business that you're in. But how do you think through where blockchain might be specifically relevant? Well, obviously you want to create a business case, run some numbers, but here's some ways to qualitatively think it through. Intermediaries. Blockchain can disrupt value chains. We saw a similar dynamic in the early days of the web. You know, is there a link in your supply chain taking profits from you that's maybe performing some function today like reconciling transactions, verifying identity or authenticity? Maybe you can use blockchain here. Cross-border, if you have global boundary-spanning supply chains and interactions, this probably adds additional complexity, opacity to your business that blockchain can help streamline. Inefficiencies, obviously where there's costly, complex transactions, cluttered processes. We mentioned the whole music copyright system before. Auditability, do you have a need for traceability? We mentioned wine, art, aircraft parts. Provenance, is it difficult to prove origin and ownership in a transaction? And then finally, value and volume. High value goods, high volume, where you have the need for automation, for economic viability. However, blockchain does have some speed and scale limitations that we'll talk about. So blockchain's not a panacea. Let's go through a list of its limitations. And the important thing to remember here is that virtually all these can be overcome based on blockchain system design trade-offs that you can make. First, scale, transaction processing speed, throughput scalability. A couple of data points here. Bitcoin and Ethereum can do about 7 to 15 transactions per second. Hyperledger goes up to 1,000 transactions per second. And for comparison, PayPal can do 8,000 transactions per second, and Visa can process up to 56,000 transactions per second. Privacy is an interesting issue. On the one hand, blockchain gives you complete visibility into the string of transactions, but with Bitcoin, for example, the identity of the person is protected. Now, in a B2B application with a little digging into the transactions, you could probably look at patterns of transactions and guess which companies are attached to them. But again, with some solid system design issues and trade-offs that you can make and decisions that you can make, you can get around this by, say, requiring a different private key for each transaction. Power consumption. I've heard that a single Bitcoin transaction uses up more energy than the typical American household uses in one day. So public permissionless blockchains like Bitcoin generally use a proof-of-work consensus mechanism, and these are extremely computationally intensive. And they have to be this way if you think about it, because you're verifying the transactions among private individuals all across the world who have really no fundamental reason to trust each other. And the consensus mechanism, and in Bitcoin this is essentially called mining, involves solving these tough cryptography problems. Now, with most B2B blockchains or permissioned blockchains, you can use a simpler, what's called a proof-of-stake consensus mechanism, because there is some level of trust and familiarity among the participants. Next point, security. We're dealing with a new technology. It's very unproven. It presents a whole new attack surface, and we just don't know exactly where the weaknesses are. I'll give you one example. They call it the DAO, the DAO incident, as in Distributed Autonomous Organization. And this was a decentralized investment fund that was robbed of $50 million of the Ether cryptocurrency back in June of 2016. And the strange thing is that the reports really vary about how much money was actually stolen. And not only that, this quote-unquote theft didn't really break any laws, since the DAO, the DAO, was based on smart contracts, which doesn't mean that they were necessarily legal contracts. Final point on this slide, the evolution of the code, governance issues. We're seeing a lot of, let's just say, debate among the Bitcoin community, the Ethereum community, about who and how, or even if you update the code, and if you can update the code, the blockchain, when you find problems, when there's changes in the operating environment. So that's a list of blockchain's limitations, its weaknesses, and let's move on and place blockchain along, let's call it a centralization continuum. On the far right of this slide, you have today's traditional centralized databases, and moving to the left, we have permissioned, also known as private blockchains, and then permissionless or public blockchains and hybrid environments in between that incorporate elements of both permissioned and permissionless. A public permissionless system is essentially open to anyone to participate. So anyone can use, purchase, accept Bitcoins, for example. Anyone can become a miner of Bitcoins, and the transactions are transparent, but they're completely anonymous, and this is why Bitcoin can have a bit of a bad reputation, because let's face it, the bad guys do use it. It's a common form of payment for ransomware. Now, the price you pay for this openness is speed or lack of it. As we mentioned before, when you have a completely open global system like this, trust is inherently very low, so that mining process to accept, verify, reconcile transactions is very costly. A private or permissioned blockchain allows for as much control as you want. So R3, as I mentioned before, is a consortium of about 70 of the biggest financial institutions in the world. And if all the participants in the system are known to each other and there is some inherent level of trust, this lets you tailor a consensus mechanism that doesn't require a lot of compute resources, a lot of energy. And one final note about this slide, this really is a fuzzy continuum. You can take an open public platform like Ethereum, for example, and apply certain rules to it, and it essentially becomes a private system. We have two sections in this webinar, and this is the last slide in this first section where we've dug into what potential blockchain use cases exist and what the limitations of blockchain are. And we've seen that blockchain solves a lot of data integrity problems and identity problems, but there's a difference between securing data at rest and securing data in transit, and this is where the network comes in. So blockchain, for example, does nothing by itself to protect private keys, and many blockchain systems rely on standard public-private key encryption. And one of the biggest breaches occurred with the Mt. Gox Bitcoin exchange, and Mt. Gox launched in 2010. By 2013, it was handling 70% of all Bitcoin transactions. However, in 2014, it abruptly suspended operations and declared bankruptcy. And this was after losing hundreds of millions of dollars that had gone undetected over years. And again, the interesting thing, like the DAO attack that we talked about before, no one really knows how the theft occurred, but most experts say that somewhere along the line, private keys were stolen. And how do you steal private keys? Well, there's a number of ways. Some just standard social engineering, anything from digging through trash cans to phishing emails to get passwords, all the way to all types of malware that's out there today. And Juniper, along with other networking players, has a line of security products and services to protect against this. And in Juniper's case, we have this roadmap that we refer to as SDSN, Software-Defined Secure Networks, that we'll talk about a little bit later. Let's move into some implementation issues and what role the network can play. And as you think through the problems that you have in your business and you start matching up the capabilities of blockchain and how you might be able to use it, the inevitable question of how do I get started will come up. We think the keys to success are, number one, system design and alignment. So do the business case. Is the proposed blockchain solution better than another solution that might be simpler and more conventional and easier? Are there non-economic factors present? Is there a powerful incumbent that will fight you? And then carefully go through the trade-offs that you have to make and align all of those decisions about application and system and deployment design with the needs of the particular use case and the participants involved. Number two, security. Trust, identity, data integrity, this is what you're solving for, essentially. Don't let a vulnerability in network security destroy all of that. And number three, cloud infrastructure. As virtually all enterprises are moving most, if not all, of their applications to the cloud, so goes blockchain. And the concept of cloud is also changing to include distributed cloud architectures that might include some edge compute resources. And the big public and private cloud providers, IBM, Microsoft, Google, Amazon, will most likely play a role in your blockchain solution. Deployment considerations. We discussed the limitations of blockchain a few slides ago, and these limitations can be mitigated through a variety of design and deployment decisions. So here are some of the questions you can go through as you start to think about deploying a blockchain solution. Where will you deploy the blockchain app? The end user device, laptop, mobile. Do you need IT at the network edge? If you're running a smart contract, you do need at least some minimal amount of IT resources, maybe in the form of VMs or containers. How will you use public cloud providers? How will you use private cloud providers or your own enterprise data centers? And if the answer is all the above, orchestrate that multi-cloud sprawl. Okay, next, which type of blockchain system will you use? Public or permissionless, private, permissioned, or hybrid? Combination of both. Who will participate and what access will they have? The users, read-write access, governance. Is a system for a well-defined set of companies in the supply chain where everyone is to some extent interdependent, in it together? If so, then a private permission blockchain with some amount of centralized rulemaking probably makes sense. And last question, how? How will the consensus mechanism align with system requirements? Again, for open, permissionless blockchains, you'll probably want a heavy proof-of-work-like mechanism. So you can loosely think about the steps to implementing blockchain as the following. But keep in mind, these aren't necessarily in perfect sequence. There could be a lot of iteration going on here. Number one, pick a use case. Number two, find a developer to build the blockchain app, assuming that you don't have the expertise in-house. I recently saw that there are 10 million Java developers in the world and only 30,000 blockchain developers. Step three, decide whether you're going to go with permissioned, permissionless, or hybrid. Decide the consensus mechanism. Step four, select a platform such as Hyperledger or Ethereum. Step five, decide where to host the app. And IBM, as of right now, seems to be the leader among all the big cloud providers when it comes to hosting real blockchain projects today. Here's a quick view of the overall architecture stack. So you can think of blockchain as a platform as well as an application built on top of that platform. And we've called out Hyperledger on the right side of this slide as an example. And lower down the stack, Juniper's Contrail suite provides the management of the physical and virtual infrastructure and the service orchestration and management of the blockchain applications, whether they're running in VMs or containers. And these are often referred to as DApps, and the D is for distributed. On this slide, we're placing blockchain in the context of the network and distributed cloud architectures that we're building out today with many of our customers. And we envision blockchain and smart contracts playing an important role in many IoT applications in the future. So it's very much tied into those discussions about where to place your network, IT, compute resources, and these decisions are based on requirements of the use case. So latency, do milliseconds matter? Traffic, is edge compute necessary to aggregate and manage a group of devices? Can you perform analytics at the edge rather than sending all of the data to the cloud? Reliability and resiliency. Will a distributed architecture improve application reliability? Security and privacy. Does sending data to the cloud present additional risks? And then back in the traditional cloud, we have IBM, Azure here. They provide a wide range of blockchain solutions. Still embryonic at this point, still evolving. And again, all the way at the bottom in terms of underlying network infrastructure and security, Juniper's Contrail platform and Sky services play a key role in these distributed cloud architectures that we're building out and using to run applications. Blockchain is part of that broader security discussion that I think every company is having today, or at least should be having, and network security is a part of that too. And at Juniper, our vision, and it's more than just a vision, it's a roadmap that we've been executing on for a couple years now. We call it Software-Defined Secure Networks, or SDSN. And our SDSN framework uses a bottoms-up and a tops-down approach, and it consists of three main components. First, you use the entire network infrastructure, switches, routers, firewalls. Each element is a threat detection, threat intelligence, policy enforcement point. Second, use the cloud. Security intelligence feeds from all sources, including third parties, and this includes cloud-based scalable malware detection. And by using the economics and the scalability of the cloud, you amplify your detection and remediation capabilities and widen your capture net and overall make it stronger. And absolutely no company out there can fight the security battle by themselves. So we use many partners, and we're very open to that, both philosophically on the business side of things and both in terms of technology, APIs, and architectures. And the third component of SDSN, centralized policy management and control. And the key here is that the threat environment today is very dynamic. The threats are constantly evolving. Blockchain certainly comes to mind. There's a lot of uncertainties around blockchain. We've mentioned this before. We just don't know what we don't know. There will be plenty more zero-day threats when it comes to blockchain. Threats and breaches that we haven't seen before, and it's going to require a lot of speed and dynamicism, and this is where the cloud and our SDSN and our Sky ATP security services will really help, we think, down the line. So your policy engine has to adapt to this environment and execute the policy by communicating it to all network elements, including third-party network devices such as wireless access points and third-party switches, that is, not just Juniper. So we've basically come to an end of part one of this webinar series, and I wanted to end it here on the topic of security. At its essence, blockchain is about security. It's about trust, ensuring identity, authenticity, and this assurance that blockchain can bring is very timely in this era where many people essentially are questioning the authenticity of almost everything, news, information, products, and I think this is one of the downsides of the overall increasing digitization of business and society. So as well as secure networks are a big part of the solution to this problem. Thank you for your time today again, and please stay tuned for part 3 of this webinar series where we dig into the blockchain opportunities specifically for network operators. And I'll be joined by a special guest to help us work through these issues.